Hello everyone, it's me Chris and welcome back to my YouTube channel. And in today's video, I'm going to be showing you guys a formula that I've just recently discovered. This formula is named general loop form after me and it's going to help you to find the values of large series with ease, alright, in just a matter of 3 lines. So take an example of a series whose general term is 3x plus 1 and it runs for about, let's say, 10,000 times, right? It takes hours to calculate it, and even in calculator, a normal calculator, it shows AC break. But using this formula, you can calculate it in matter of 3 lines, 3 to 5 lines. I know, right? That sounds OP, but I guarantee you that it's not a clickbait. It's worth every second of your time. So stick around this video and yeah, hope it helps. I hope you guys can see the derivation that I've used to explain the concept right here in my right side. And okay, let's go. So for when starting value is 1 only. Basically here I've let two series. First one is summation ax plus 1 where the starting value is 1 and the loop terminates till 4. And in second, the starting value is also 1 but its general term is ax plus 2 and its looping value is 5. Here a is coefficient of the general term, everybody knows it, and I have increased the general terms by the common difference of 1. So in first series, when the coefficient of the general term is 1, 2, 3 respectively, the series increases by the gap or the common difference of 10. So in first it was 14, in second it was 24, and in third it was 34. And in second series, when the general term was 2, 3, and 4 respectively, the series increased by the gaps of 15. So in first it was 14, in second it was 55, and in third it was 70. We can all agree that the common differences are 10 and 15 respectively. Here below that I've created a basic structure of a series. As you can see, the above one is the looping value, the below one is starting value, and in right hand side there is the general term, and it is all contained in a summation or sigma. Okay, and also the important part is that I've mentioned the final value f. Okay, so the value that comes after evaluating the series, I've let it f. Now, after the experimental verification, in the first two series, the difference increases when the first coefficient of the general term increases. So let me go back to that series. As you can see, I've let two series, 4n is equals to 1, ax plus 1, and 5n equals to 1, ax plus 2. When the coefficient a had increased by the common difference of 1, so in first it was 1, 2, and 3, and in second it was 2, 3, and 4, you can see that there is a separate difference for every looping value. There's a separate difference for every looping value. In the first two series, the difference increases when the first coefficient of Tn increases in a fixed order. This statement tells us that when the general term's first coefficient increases, then the whole difference of the series increases in a fixed order. As you can see in the example I've given, when the looping value was 4 in the first example, the difference d was 10. But when the looping value was 5, the difference became 15. And so on for other looping values. So from this experimental verification, we can find out that there is a different common difference for every different values in the loop. So in conclusion, we can say that the final value increases in a fixed order when the general term's first coefficient increases. Hence, when we can come to a conclusion that there must be a different common difference for every looping value. Then I used my 200 IQ and find out the common difference of first 5 consecutive numbers. You might be wondering why I did that, but trust me, it's gonna show my IQ. Wait. I find out the first 5 consecutive numbers difference. So of 1 it was 1, of 2 it was 3, of 3 it was 6, and of 4 it was 10, and of 5 it was 15. I then formed a sequence like this, and it was a quadratic sequence. So for those of you who don't know what quadratic sequence is, it's basically a sequence whose second common difference is equal. Then I thought to myself that if I can find the general term as this sequence, then I can technically make an equation which would help me to find the difference of any numbers, which will then allow me to find the common difference of every single number that you can imagine. Then I found its general terms by using the process of finding quadratic equations general term, and it was n squared plus n by 2, or n bracket n plus n divided by 2. So this general terms gives the different differences of different loop values. So using the above data, I figured out a formula which works to evaluate any series whose starting value is 1. Alright, as you can see in the thing that I've written down, I have some terms that you may want to remember while solving using my technique. In it, you have to keep in mind about 5 things. They are the result or the final value of the series, the looping term or the value, the difference between loops, the first coefficient and the second coefficient. And the formula is f is equals to AD plus minus BL, where f stands for the value which we want, A stands for the first coefficient of the general term, D stands for the common difference between them, B stands for the second coefficient of the general term, and L stands for looping value. And that thingy right there, plus minus, it's not a big thingy. Actually, I've just written it down so that it works for any plus and negatives. If the general term is 3x plus 1, then we use the plus in between, and if the general term is 3x minus 1, then we use the minus in between. It's not that complicated. I've just written it out so that you can use the required addition or subtraction present in the general term. Addition, division and subtraction are all the same in this process except multiplication, because it gets complicated from there. So I've provided it in another section. Right, for now, just keep in mind that this formula only works for plus, minus and division. Alright, so yeah, this was the formula. F is equals to AD plus minus BL, and this is how you solve problems using it. For example, I've given an example. It's summation where n starting value is 1, where looping term is 101, and the general term of A is 3x plus 1. I firstly did the solution, and then I found out the common difference of the looping value. So in this case, the looping value was 101, and then I put 101 to the general term of the previous common difference, which was n squared plus n by 2. I substituted it in the value of n, which gave me 5151. Now we chuck this value into our formula of general loop form, which is f is equals to AD plus minus BL, and there you go, the answer is there. And yeah, like this, you calculate the values of the series, large series whose starting value is from 1. And remember, it only works for plus, minus, and division. Of multiplication will be there.
For now, peace out.